Hi, I'm Nick Guida. I'm the founder and CEO of Tamarack Aerospace Group, and I'm excited that we're going to bring another Flying with a Founder to you guys. So today, this one's going to be about minimum control speed. VMC is what we say, V and then a little MC, minimum control. And this is for aircraft, multi-engine aircraft. Because single-engine aircraft, if you lose an engine, the airplane is a glider at that point, and you don't have other things to consider. But when you have two engines and you lose an engine, you have to think about how the airplane flies. What's the slowest you can fly to still maintain control and be safe? So there's regulatory, of course, and you have to demonstrate this. So is your elevator or rudder or wing or dihedral, all that stuff designed properly so that if you lose an engine, that you can still safely fly this aircraft, continue to fly and land it? So there's two kinds. There's VMC-A in the air and VMC-G on the ground, and you have to show both. So if you're rolling down the runway and you lose an engine, your rudder has to be able to get you back onto the center line as you're reducing thrust and those type of things. But according to the regulations, you can't just rely on the pilot bringing back the thrust on a roll, takeoff roll. So there has to be some period where you need to be able to maintain control. So the way you do VMCG is, so just think about this, like it's a pretty complicated situation when you're taking off. As you're accelerating, the airplane needs to be able to reach the speed that it can take off, which is generally 1.05 times the stall speed in that configuration, and then climb out. And then you can lose an engine, and you still have to be able to control the aircraft. So the speed has to be high enough to control the aircraft and still maintain safety margins. So let's talk about VMCG first. So the way you test VMCG is you disconnect the nose steering wheel so that you can't steer with the rudder. You can't steer with the pedals. So the first thing you do with VMCG is you disconnect the nose wheel steering, and you can only control the direction of the aircraft with the rudder, aerodynamic forces on the rudder. So what you do is you run down the runway without the nose wheel touching or connected, and you use an aft CG, which makes the nose basically just bounce. You can't have the nose wheel have much pressure on it at all. So the FAA regulating authorities do not want you to be able to steer the airplane with the nose wheel. You can only steer with the rudder. You run down the runway, and then the guy in the right seat chops one of your engines, and you have to react and keep the airplane within 15 feet of the center line of the runway until you slow down. You can't exceed that and come back. So your job as a flight test pilot is to run down the runway. He'll surprise you, or she'll surprise you with the engine cut, and then you step on the rudder and try to bring it back. So you can imagine that we have to do this test, and we used the Bruntingthorpe in England. It's a 10,000 foot runway. We were able to do this. So this is one way to establish and demonstrate that you have the speed at which you can lose an engine and still be safe is a certain speed. That's called VMCG. VMCA, you do the same thing in the air. You have to be able to lose an engine and still maintain control. So what you'll do is you start fast at 120 knots, 130 knots, lose an engine, and you can still control it. Then you slow down another 10 knots and you can control it. And you keep doing that until the airplane is not controllable. Then you say, that's it. You can't go slower than that. So then you put markings on your instruments so that you know, as you train as a pilot, you have to stay above that speed if you do lose an engine. Don't slow down too much, or you don't have enough residual control authority to be safe and continue the safe flight and land. So these are the type of things that come into play when you have multi-engine aircraft, and you have to maintain control with only one engine. And as a flight test pilot, it's a pretty exciting ride in cases because you are pushing the limits of the margins, and you have to slow down until the point is, hey, that is not controllable, and you recover, and then you say, okay, there's our number. So in order to comply with the Federal Aviation Regulations, or EASA regulations in Europe, you have to demonstrate that these aircraft are capable and safe at above a particular airspeed. And this is what you're doing during these flight tests. At the end of the day, when you present the FAA a body of evidence and they're on board during these tests to show the compliance to the regulations, you know that there's adequate safety margin for a pilot of normal skill that's able to do these maneuvers and stay safe flying the aircraft. So thank you for tuning in. I'm looking forward to doing more of these in the upcoming weeks. And remember, Tamarack takes you further.